Pre-algebra, Chapter 10, Section 5, using sampling to predict. So sample is just a small group chosen out of a much larger group. A population is the larger group a sample is chosen from. So for instance, when we go into voting, they like to predict who's going to win. So what you do is you have your greater population and you grab a random sample, and you call them on the phone and you get them to answer some questions about who they are going to vote for. And that who you call is your sample out of your population. But you can have different types of sampling. You can have unbiased sampling, which is what we want, and it's representative of a large population. It's selected at random without preference, and it's large enough to provide accurate data. So number one, the double dot plot shows Jada and Angel's number of hours worked 1 week at their jobs. Compare the centers and variations of the two populations, who typically works a greater number of hours in a week. So this is a dot plot, which means that I need to do mean. And the mean average deviation. Let's see, so the MAD. So the mean, and what I can see already is that Jada is more consistent because she is symmetrical in her data, whereas Angel is not very consistent, but I will say he probably works more hours. So 6, so add them up and divide by how many there are. 6 plus 7 plus 7 plus 8 plus 8 plus 8 plus 8 plus 9 plus 9 plus 10 divided by, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 divided by 10. So we get 8. This is for Jada. This is for Angel. Angel is 5 plus 7 plus 8 plus 8 plus 8 plus 8 plus 9 plus 10 plus 11 plus 11. Again, divided by, I'm assuming 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep, divided by 10, so that's 8.5. So on average, he is working more. So Angel is working more. Is working more hours. And still, we're going to get our information here. So 8 minus 6, so that's 2, plus 1 plus 1, plus 0 plus 0 plus 0 plus 0. Plus 1 plus 1 plus 2 divided by 10. So we have a deviation of 0.8 between each one. And then we have 3.5 plus 1.5 plus 0.5 plus 0.5 plus 0.5 plus 0.5 plus 0.5 plus 1.5 plus 2.5 plus 2.5 divided by 10. And he has an average deviation of 1.4. So he's definitely not as consistent in how much he is working. Let's see. But he also works more. Number 2, test practice. Candace used a double box plot to compare the monthly amount of babysitting money she brought home the last 2 years. So you can see that this year is a little more consistent because her box is more symmetrical. And she's also working more this year because it is the lower quartile and the upper quartile are both greater than last year. Okay, how many dollars more was this year's median amount of babysitting money compared to last year? So this year median was around 110, and last year's was around 95. So it's around $15 more. How are statistics used to draw inferences about and compare populations? Well, today we'll see that you can identify various sampling techniques, and you can determine the validity of a sample and predict the actions of a larger group. So determine the types of music at concert halls customers like best. All the people attending a country music concert are surveyed. Identify the sample as biased or unbiased and describe its type. So if we come down here, hold on, let me get to it. We have unbiased samples. So unbiased samples are simple random samples. So the definition is each item or person in a population is as likely to be chosen as any other. So an example is 30 student ID numbers are randomly selected. You can have a stratified random sample, is when the population is divided into similar, non-overlapping groups. A simple random sample is then selected from this group. So a population of election districts can be separated into urban, suburban, and rural. Those do not overlap. Urban, suburban, and rural are very different places. Systematic random sample is the items or people are selected according to a specific time or interval. So every 20 minutes a customer is chosen, or every 10th customer in line is chosen. So that's systematic. Here, we have bias samples. We don't want bias samples because it's not going to give us good data and we can't predict anything. So a convenient sample includes members of a population that are easily assessed. So the first 10 students to come into the cafeteria, that's a convenient sample because you just wanted to get it done. You didn't do it randomly and find a good pattern. Or you can do voluntary response sampling. So that involves only those who want or can participate in sampling. So the principal sent an email to graduating seniors asking them where to hold commencement. Seniors are asked to vote through an online poll. So that's a voluntary response. So they voluntarily go and answer those questions. So here, to determine the types of music and concert halls customers liked best, all the people attending a country music. Well, if they're only attending a country music concert, they may not necessarily like anything but country music, so you're not going to get anything but what is already there. So since the attendees at a country music concert probably prefer country music, the sample is biased. So the sample is a convenient sample since not all the people surveyed are in one, or since all the people are in one location. So a hardware store wants feedback on its products and services. The store includes a telephone number on each receipt so customers can call and participate. They can call. That's biased. It's voluntary response. The sample includes only those customers who choose to participate. So it's a biased, voluntary response. Make sure you have that down on your paper. A pet store mailed a survey to residents to determine their favorite pets. 50 people responded, and the results are shown in the table. Is this sampling method valid? Well, they are the ones sending it back in, so that means it's self-selection. So they are, it's not convenient, but it is them voluntarily responding. So it's a voluntary response sample. How many people can you expect? So since it involves only those who want to participate in the survey, therefore the sampling method will not produce an accurate and valid prediction, so I don't have to predict here. Mr. Stevens surveyed every 10th student in the hallway to see where they would prefer to go on vacation. So he's in the hallway, it's random people walking by, so every 10th. Okay, so this is an unbiased sample. 48% preferred the beach, 36% preferred an amusement park, and 16% preferred the mountains. Is this sampling method valid? Yes. If so, how many of the 560 students in the school would you expect to say they preferred the beach? The beach was 48%. And the only way you can find the percent is to take the percent, change it into a decimal, and multiply times the whole. In this case, 560 students. 4,800 times 560 gives you 268.8 students. So you can't have part of a student, so they rounded up to 269 students would prefer the beach in this systematic random sample. From a batch of 7,500 computer chips produced, the manufacturer sampled every 150th chip at random for defects and found that 2 were defective. So 2 out of 150 were defective. Is this sampling method valid? Yes, because it's random. If so, find how many of the 7,500 computer chips you can expect. 2 ways to do it. You can take 2, divide it by 150, and you get, let's see, this is a systematic random sample. Did I do something wrong? Because the samples are selected according to a specific interval. So the sampling method is reasonable and will produce a valid prediction. Yes, since every 150 chips were sampled, there were a total of 7,500 divided by 150, or 50 chips sampled. Ah, okay. There we go. That's what I messed up on. So you have 7,500 chips divided by how many times you took a sample. So 50 chips were sampled. 50 chips were sampled, so 2 out of 50 were defective, which is 4%. Okay, so 4% of 7,500. So to find how many are defective out of the entire batch, we take 4% times 7,500. You can also take 2 out of 50 and use proportion if you would like. It's up to you. So you would expect approximately 300 defective chips. A middle school planned to play music during lunch. To determine what type of music students preferred, 25 students with MP3 players in one lunch period were surveyed and asked what type of music they preferred. You should already be able to tell me how biased this is. 25 students, they had to have an MP3 player, and it was during one lunch period. When they have multiple lunch periods, this is so biased. It's a convenient sample. Someone didn't really want to do their job. 16 said they preferred country music. Is this sampling method valid? No. If so, find how many of the 535 students in the school can expect to prefer country music. A biased, convenient sample, since only students with MP3 players in one lunch period were surveyed, so the sampling method will not produce a valid prediction, and we do not need to come up with a prediction. Here is all of our vocabulary: sample, population, unbiased sample, random, simple random sample, stratified, systematic, bias, convenience, voluntary. You have all of that information here in your concept summary as well as in your book. You can go look there as well. Bias samples. So how are statistics used to draw inferences about and compare populations? Well, we talked about that a little bit ago. Identify various sampling techniques, determine the validity of a sample, and predict the actions of a larger group. Make sure that you are looking back at this today to determine what is biased and unbiased. Look at these. Make sure you know and you get it right.